All right, today we're looking at rectangles and their properties. So rectangles fit under quadrilaterals, meaning they have 4 sides. Quad means 4. Rectangles have the same properties of parallelograms. So the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, and consecutive angles are supplementary. So same side angles add up to 180. Diagonals bisect each other, bisect meaning cut in half. And we're going to add 2 more properties on top of that for rectangles. All 4 angles are right angles, meaning they're all 90 degrees. And the diagonals are congruent, meaning they are the same in value. All right, so let's look at the first one here. We are going to look at just the sides on number 1. So if PS is 10, that means QR is 10. Opposite sides are congruent. PQ is 24, so SR is also 24. So QR is 10, SR is 24. PS, do we need that one? I'm doing all the ones that aren't the diagonals yet. PR is a diagonal, and QT is a diagonal. So we're going to have to do a little bit more work to figure out those diagonals, but it's not too bad. So our diagonals, you'll see, go across through the center, okay? And we do know that these form 90-degree angles. So if we have a 90-degree angle, and we're cutting this in half, you'll notice we have a right triangle. And to find a missing side of a right triangle, we use Pythagorean theorem. Okay, so Pythagorean theorem is a squared plus b squared equals c squared. And remember, the only thing that really matters here on Pythagorean theorem is c is always the hypotenuse, and the hypotenuse is found across from the right angle. Okay, so it doesn't matter which one you label A or B of those 2 sides, but the hypotenuse has to be, trying to get that to focus better for you guys, it has to be that hypotenuse is C. Okay, so here I have 24 and 10 as my 2 sides, so again, I'm not going to hesitate or get hung up on which one I'm going to call A or B, but C is the one, SQ is what I'm looking for here. So let me get my calculator to square that. So we get 576 plus 100 equals c squared. So we get 676 equals c squared. Now if you remember, the inverse operation of squaring a number is to take the square root. So if I need to get rid of a square, I will simply square root both sides of this, and that will cancel that square, and c is left all by itself. So in my calculator, let me grab one real quick. Okay, to get to the square root symbol, you're going to hit the second and x squared button, and there's my square root, and I get 676, which is 26. So here, my C is representing SQ. That entire thing is 26. And if diagonals are congruent, PR is also 26. Okay. Now, going back up here, because they're asking for QT, which is this segment right here. Let me see if I can color code it for you. I think I'm getting too many of the same shades. Let's do red here. So QT is found right here, and if you go back where it says they bisect, remember bisect means they cut in half. So half of 26 is 13. So that means all of these little segments would be 13. So try number 2, and we'll see how you did. Okay, I'm going to look at number 3 next, where we are focusing on the angles. So number 1, we are focusing on all of the segments. Now we're looking at angles. So just kind of review, I know that all 4 angles are equal 90 degrees, opposite angles are congruent, and consecutive angles are supplementary. Okay, so those are the properties I'm going to use here to help me. And it's good to use maybe colored pencils, or if you're going to use different colored pens here, make sure you have a good whiteout just in case you make a mistake. So I'm going to get some colored pens so we can label everything, and I'm going to have to write very small. Okay, so it's actually pretty awesome that I can find all of the angles inside of this rectangle just by being given the one angle that's 27. Okay, so let's get started. First, I'm going to focus on my 4 corners, right? Because I know that each of these total 90 degrees. They're right angles. So if I do 90 minus 27, I get 63 degrees. Okay, so where can I go from there? Well, if I use parallel lines cut by a transversal, where this is my parallel line, and this is my transversal, I'm going to say alternate interior angles are congruent. So if I alternate this and put 27 down here, then that would mean 90 minus 27, or alternate interior angles on this one is 63. Okay, so it gets a little confusing with these because we are going to pull so much information that you have learned already in the past, okay? So they told us that our diagonals are congruent. Well, if those are congruent, I'm creating isosceles triangles. And isosceles triangles, their base angles are also congruent. So that means this one would also be 27. And then I can use isosceles triangle again, or I can use alternate interior angles to say that one would also be 27. And then by complementary angles, this would be 63. Or again, because these two are also isosceles triangles, I can say that that's 63 degrees as well. So there's a lot of reasoning here that I can use using all those fancy math words. Okay, so they've given us one angle measurement, and we have been able to find 1, 2, 3, 4, 5, 6, 7 other angles just by that one. Rectangles are awesome. So there's actually one more set of angles that I can find, and those are, I think I got all green pins. Oh my goodness. Okay, maybe the yellow will be okay. Sorry. So we're going to focus on these interior angles right here. We can also find those. Okay, I'm going to use this little triangle right here, but you could use any of them. Okay, I know these are isosceles triangles, so I'm going to take my 180 minus 63 minus 63. Now, I could have done it for the other one as well. I could have done 180 minus 27 minus 27. Okay, so just pick one and go from there. Sometimes it's hard to do, so don't stress. Pick one of them. Now I'm going to get my calculator. Here we go. 180 minus 63 minus 63. I plugged it in wrong. 180 minus 63 minus 63. And I get 54 degrees. So that means this one is 54. And then by vertical angles have not left us. Those are also 54 degrees. Okay. So now, if I do 180 minus 27 minus 27, again, I'm just plugging all that into my calculator. My calculator's going to do all the work for me. Except, oh my goodness, look. The calculator is only as smart as the person using it, you guys. If you don't plug it in right, it's going to give you the wrong answer. So I like to plug them in a couple times. You'll see I kept making silly mistakes. So don't be afraid to just plug it in again a couple times just to be safe. I knew that, see, they told me it was 26, but look at this. This is an obtuse angle here. So I knew I made a silly mistake somewhere. So just kind of use your common sense. If your brain's saying, wait a minute, that doesn't look right, it's probably correct. So go back and double check. Alrighty. So I like to do all this. I know it looks so messy right now, but if you're, doing one little thing at a time, it's not going to be so overwhelming. But if you are just like fast forwarding or pausing this video and you're not really following along, you're just like going to the end and then writing it down, this would look insane. So please don't do that. Really spend the time with me here on these videos, because if I walked in and just saw all this, I wouldn't have no idea what people were doing. Okay, so the next part gets a little bit crazier too, because now we have to label the angles. We're going to go from M to J to K. So M to J to K is this angle right here, which is a 90-degree angle. So I'm going to use some color coding with my colored pencils here to help me, because it gets so much information on this one little diagram that it gets overwhelming. Okay, M, J, L. M to J, but then it cuts over to L. So remember, always look at the mouth of the angle, and the number in the mouth of this angle is 63 degrees. Okay, next one. J to L to K. So J over to L up to K. Again, look at what's in the mouth of that angle, and it's 63 degrees. All right, K, M, L. So I'm going to go from K over to M over to L. So look at the mouth of that angle from K to M to L. Take your time here. 27 degrees. All right, let's see if I have enough colors here. Okay, M to N to L. So M, that is not going to work. Let me get a marker. See how overwhelming it can get? M to N over to L. So it takes this little turn right here. And what's in the mouth of that angle is that obtuse angle of 126 degrees. So again, if I just walked in and saw that, I would have no idea what that person's thought process was. So feel free to rewind this, go back one little step at a time, because it's very overwhelming when you look at this once it's done, because that just looks like an awful mess. Okay, so please actually watch this video. Don't just skip through it, or it's going to be very overwhelming. Okay, let's look at, I'm trying to look here. Let's go to the back and I'll work out some of those because they have expressions in them. Okay? All right. Okay, well, I think you're going to be okay on number 6, but let me go ahead and help you get it set up just a little bit. All right, so they're asking us to find EF, segment EF. Well, they have given you in the diagram EF and CD. And if you go back to the properties listed, opposite sides are congruent. So I can say segment EF is congruent or equal. Since we're plugging in numbers, I'm going to say equal to CD. So you just set these two equal to each other, solve for X, and then substitute back in for EF. Okay. My pen's about to die. I'm going to have to change colors on you here. Okay, number 7. They've told us what RT is, and RT is a diagonal. I'm going to go ahead. I like to color code. I am a color coding person. So RT is this. Okay. And US is that expression. Well, we know by looking at our properties, I'm going to flip this back over, our diagonals are congruent, meaning in value, they would be equal to each other. So again, I'm going to say RT is equal to, ooh, that was wrong. Oh yeah, no, RT is equal to US. Now, always be careful, and I'm going to be honest, sometimes Miss H messes up here because I'm always solving for x, solve for x, solve for x, right? Go back and make sure, is x where you stop, or are you having to plug x back in like we had to here, okay? So then you would go back, and once VT, okay, so VT would be RT, right? And then we'd have to cut it in half, divided by 2. So plug that in, whatever your 5 times whatever your x is minus 14, and then you're going to cut that in half, because if you remember on the other side, diagonals are congruent, but they also bisect each other, so they're cutting each other in half. So these two sections are the same. Okay? All right, let's see what else I can do here for you. Okay, let's look at number 9. It looks like it's a little bit tricky. Okay, so color coding again. VW, oh, it's just half of that, right? And SU is the whole thing. Oh, it is a little trickier. And if you want, you can actually go ahead and label this 9x minus 11, but this thing is, the whole thing is 16x minus 12. Okay, well, what do we know about diagonals? That they are congruent and that they bisect each other. So that means this other half right here is also 9x minus 11. And sometimes I struggle with actually just being okay labeling it the same thing. I always think for some reason, like, well, that must be too easy. It's so easy that it must be wrong. You know, kind of those thought processes that we get sometimes in math. But you're good. Yeah, if these bisect each other, if this is 9x minus 11, so is the other half. So, but I'm a little bit lazy. Okay, let's put VT, right? VT is equal to SU. I think that's where I should start here to solve for x. I am a little bit lazy, so I hope you guys are okay if I put 2 times 9x minus 11 equals 16x minus 12. I just don't want to put 9x minus 11 plus 9x minus 11, okay? Some of you could probably just double that in your head without even thinking. So go ahead and feel free to do that. Now we're going to razzle-dazzle with some algebra here. Distribute, combine, rearrange, same steps, always over and over and over again. 16, 17, 18, 2x. I feel like I'm going to get that wrong. Times when I see that you have the easiest problems, I think that it should be more difficult. Okay, so I know x is 5, so we're good there. Now I need to go back and make sense of what are they asking for, because it wasn't x. So unfortunately, I am not done. I wish I was, but I'm not. Okay, so WT is just this little piece right here. Oh, but look, we know what WT is. WT is 9x minus 11. So that's okay. I'm going to put WT is 9x minus 11. And then I'm just going to substitute my 5. Don't forget your parentheses, Miss H, or you will get that wrong. So then I get 45 minus 11. So WT equals 34. So it started off kind of looking a little crazy, but once we got everything labeled, it wasn't too bad. Okay, I'm just kind of glancing over them. Let's look at number 12. 12 looks a little tricky here. Well, maybe not too bad. Again, now we're looking at angles, so I know that together they make 90. And if that's a transversal, I know that alternate interior angles are congruent. So that one's actually not too bad. So I know here to solve for x, because I want to be able to compare my x's, that x plus 20 plus 5x minus 8 equals 90 degrees. They're complementary angles. So I'm going to stop there. I think you can solve that. And then I'm just going to double check, what are they asking for? They're asking for x, z, w. So they're asking for x, z, w. X to z to w, the mouth of the angle would be right there. So whichever expression you should plug in and solve for, that would match that angle. Alrighty. One more here to go. Let's look at 13. I don't know why, I just have this feeling about 13. So we're going to solve for x, and all they've given me is this one little angle right here, DGH. And this 134. So my brain's like, okay, I see vertical angles, but I don't think that's going to help me here. I know that's also 134. So it's okay to go through all these thought processes of kind of sifting through all this knowledge that we have obtained. Well, I know that if these are isosceles triangles, right? So that means this angle is also 5x plus 7. So what's this angle? Oh, look, it's a linear pair. A linear pair. So I'm going to take my 180, subtract 134, and that's 46. So I know that these two angles, and again, I'm going to be a little bit lazy here. I'm just going to double that so I don't have to write twice. Plus the 46 equals 180 degrees, the interior angle sum of this little triangle right here. So I'm just going to use this little isosceles triangle. And then that, oh, now we just solved for x. So that one wasn't as wild as I thought it'd be. All right, you're going to work on the rest of these in class and finish those up after you do your notes. So there we go. Properties of a rectangle.